In this graph, in this example, we're going to sketch the graph of y equals 1/2 x cubed by plotting points. And we've been given some points to plot here. We've been given the x's. We want to find the ordered pairs for those x's. So if x is equal to -2, y is going to be equal to 1/2 times -2 cubed, 1/2 times -8, and that works out to be -4. So we would write the ordered pair -2, -4. And we can plot that, -2, -4, would be about right here. Okay, if x is equal to 0, y is equal to 1/2 times 0 cubed. Following order of operations, 0 cubed is 0, and 1/2 times 0 is 0. So we get the ordered pair 0, 0. Right, then we have x equals 1. So y is equal to 1/2 times 1 cubed. That's 1/2 times 1, that's 1/2. So 1 and a half is my ordered pair, 1 and a half. And I have x equals 2, y equals 1/2 times 2 cubed, 1/2 times 8, and 1/2 times 8 is 4. So we have the ordered pair 2, 4. That would be here. So we're going to get our curve to look something like that. It has a little squiggle in the middle. Find the x and y intercepts of the graph of the given equation, 4x minus 5y equals 12. So we're going to find an x-intercept by letting y equal 0. So that's 4x minus 5 times 0 equals 12. 4x equals 12, divide by 4, and x equals 3. I like to write my x-intercepts as ordered pairs, 3, 0. But if I look in my directions here, it says to enter them as integers or fractions. So we would just write x equals 3 for our x-intercept. Now we find a y-intercept by letting x equal 0. So that's 4 times 0 minus 5y equals 12. So negative 5y equals 12. Divide by -5, and y equals -12 over 5. So that's how I'm going to write my y-intercept, -12 over 5. For this question, we want to write the standard form of the equation of a circle described below. Our circle needs to have a center of -7, 5 and a radius of 7. So in order to solve this problem, we need to know the standard form of a circle. The standard form of a circle is x minus h squared plus y minus k squared equals r squared, where h and k are the coordinates of the center of the circle and r is the radius. So for r's, we have h being -7 and k being 5, and we have the value of r being 7. So I'm going to substitute these values into the equation of the standard form of a circle. That would give me x minus -7 squared plus y minus 5 squared equals 7 squared. I'll do a little bit of simplifying. I don't want to leave this double negative, and I don't want to leave this squared here. So I'll write this as x plus 7 squared plus y minus 5 squared equals 49. So this is the equation of a circle with center -7, 5 and a radius of 7. Write the equation in standard form for a circle with center, -3, 5, and tangent to the x-axis. So we're trying to write the equation of a circle. So let me write down what the standard form of a circle is first. The standard form of a circle is x minus h squared plus y minus k squared equals r squared. And that's where HK is the center of the circle and R is the radius. Now we are given the center of the circle to be -3, 5, so that means we know the values of H and K. So the only other value we need to know to find the standard form of a circle is the radius. And hopefully this other information about being tangent to the x-axis will be able to tell us what that radius is. So let's have an understanding of what it means for a circle to be tangent to the x-axis. And we'll do that with a picture. So here is the coordinate plane, and the horizontal line is the x-axis. If I were to draw a circle that is tangent to the x-axis, what that means is that the circle will touch the x-axis in a single point, rather than the circle crossing the x-axis or totally missing the x-axis. So this example here, let me change the color of it. This example here is a circle that is tangent to the x-axis. So what that does for us is it allows us to determine the value of the radius. If I start to draw this picture, I think it'll become more apparent to you. So for the example that we're working with, we have a center of -3, 5, and I know that the circle I want to draw is going to be tangent to the x-axis. And so that must mean that if I go down to the x-axis, this is the point that the circle is touching the axis at. And because of that, it's really easy to count how much we are, count the distance from the center to that point on the x-axis. So this ordered pair for the center is -3, 5, so that must mean that our radius is 5 for this particular circle. So we now know the radius of the circle is 5, and we can fill in H, K, and R into the standard form of the circle. So we have x minus -3 squared plus y minus 5 squared equals 5 squared. I'll simplify this double negative and simplify the squared, and that gives x plus 3 squared plus y minus 5 squared equals 25. So we have the standard form of a circle that has a center of -3, 5 and is tangent to the x-axis. For this question, we want to find the center, radius, and intercepts of the circle given below and sketch the graph of the circle. Our circle has the equation x minus 1 squared plus y plus 8 squared equals 4. We know this is the equation of a circle because it's in the proper form. In the form of a circle, the standard form of a circle is x minus h squared plus y minus k squared equals r squared. And this matches that format. We have x minus 1 squared plus y plus 8 squared equals 4. Now the h and the k that are in the standard form stand for the center of the circle. The center is hk, and for our example, we'll use 1 for the h. You can see that the h is the value after the minus sign. So we have an x-coordinate of 1. However, on the y-coordinate, we don't have a minus, we have a plus. But every addition can be written as subtraction, and you do that by adding the opposite. So y plus 8 is the same thing as y minus a negative 8. So that number after the minus sign is a negative 8, and that is the y-coordinate of our center, or k. Then you can also see that on the other side of the equation, we have r squared. R stands for the radius. On the other side of our equation, we have a 4. So we know that those two match. The radius squared will equal 4. I can square root both sides to get r equals 2. Really plus or minus 2. But since the radius is a distance, we'll only use the positive value. So we get, for our example, that the radius is 2. So we found the center, we found the radius, and now let's find the intercepts of our circle. To find an x-intercept, we let y equal 0. This gives x minus 1 squared plus 0 plus 8 squared equals 4. X minus 1 squared equals 0 plus 8 squared. 0 plus 8, 0 plus 8 is 8, and 8 squared is 64. I can solve this equation by isolating the square. I would subtract 64 on both sides, and that gives me x minus 1 squared equals negative 60. As I continue to solve this equation, I can see that I'm going to get imaginary solutions. If I were to square root both sides to get rid of the square, I have the square root of a negative, which will produce an imaginary solution. So I know that that indicates that there are no x-intercepts for this circle. So let's move on to finding the y-intercepts. To find a y-intercept, you let x equal 0. I'll substitute 0 in for x in the equation of the circle. That's 0 minus 1 squared plus y plus 8 squared equals 4. 0 minus 1 is negative 1. Negative 1 squared is positive 1. I'll solve this equation by isolating the square. I'll subtract 1 on both sides. That gives y plus 8 squared equals 3. I'll square root both sides. The square root and the square cancel each other out, giving you y plus 8. You gain a plus or minus sign on the other side. You gain that plus or minus anytime you square root a square. And then I'll subtract 8 on both sides, giving me y equals negative 8 plus or minus square root of 3. So this circle would have two y-intercepts. one at 0, -8 plus square root of 3, and the other being at 0, -8 minus square root of 3. So the final thing we want to do with this example is to graph our circle. To graph our circle, I'm going to plot the center. We found the center to be at 1, -8. So here's the center of the circle. And then we're going to use the value of the radius. The radius is 2 for this example. So we'll, from the center, move up 2. That's a distance of 2. 2 to the left, that's a distance of 2. 2 down, a distance of 2. And 2 to the right, a distance of 2. I'm reminding you that the radius represents the distance from the center to every point on the circle. So by traveling a distance of 2 away from the circle, you're arriving at points on the circle. We're going to connect those points to create the circle. And there we have the graph of the circle. I just want you to notice that this confirms what we found algebraically. We found algebraically that there were no x-intercepts, and you can see that on the x-axis, the graph does not cross that x-axis, confirming that we have no x-intercepts. However, you can see the graph does cross the y-axis, and we did get 2 y-intercepts. Thank you for checking out my videos. Have a great day.